Hi everyone, let's go to problem 65, right? So determine the maximum value of y, which is equal to absolute value of cosine 2x minus 4 plus 3 by using t substitution. All right, so let's just try to write it down. What happened? What's happening right here? Y equals absolute value of cosine 2x, and I'm subtracting this with 4, and I'm adding with this by 3. And I need to find out the maximum possible value using t substitution. Right, so let's just try to substitute cosine 2x with letter t, okay? So if I have cosine 2x with letter t, well, for all real values of x, we kind of notice that this little t it's bound between -1 and 1. So here we go. We have -1 and +1. Okay? So now using this idea, we can rewrite this, relabel as, absolute value of t minus 4 plus 3. And where t is stuck between -1 and 1, can we sketch this? I think we can sketch what's going on here. So if I sketch the t and y graph, there's going to be 4, 3. There's going to be 4, 3 such that my vertex stays at 4, 3. But my graph, it's actually going in this direction, okay? It's going like a V-shaped graph, the usual absolute value graph, where on the right side we have the slope of 1, on the left side of x equals or t equals 4, we have the slope of -1. I need to find out my maximum value. And you can totally imagine that my maximum value will occur when t equals -1. Why? Because it's on the, like the V-shaped, the left side of the V-shaped graph, and it's actually falling. So in other words, if it's decreasing function, you can actually check that smaller values will result in larger values of y because it's a decreasing function. So I would say at t equals -1, you can check that y equals absolute value of -1 minus 4 plus 3. And I can tell you that that becomes 5 plus 3, and it totally becomes 8, and that shall be it.